You are about to learn something amazing. In this video alone, you can go from beginner to advanced in Python programming. Python. Now, why Python? Python is one of the easiest programming languages to learn, and it's object-oriented programming. That is one of the best types of programming, just like JavaScript, that you can learn today. And the great thing about Python is that the people that have Python skills, the average salary for a Python programmer is $102,000. It's a six-figure salary if you've got the skills in Python. With Python, you can build websites, automated bots that make phone calls and send text messages. You can build web scraping and web crawling tools, and you can also do machine learning. There's so much you can do with Python, I wouldn't even know where to start. And look at the companies that like to employ Python programmers. Python is an in-demand skill. We've got Google, Facebook, Instagram, Dropbox and Reddit here. If we look on Upwork, which is a website for freelancers, the people with Python skills can earn up to as much as $75 an hour. You can see here, this person is highly efficient in web scraping and crawling using Python. So who is this free course for? It's for anybody of any age, any skill level, living in any country as long as you understand English. Okay, so if you're a kid wanting to learn Python, this is the place to be. If you are retired and you want to learn Python, this is the video to be watching. But you can be at any skill level of any age, wanting a change in career, it doesn't really matter. If you want to learn Python or have always wanted to learn Python but didn't know where to start, this video is where you start. If you want to learn a valuable new skill. Now, I teach Facebook marketing, I teach social media. These are skills that I picked up about 4 or 5 years ago, and it has been absolutely life-changing for me. And a valuable new skill like Python programming could be life-changing for you. If you want to build cool web applications, Python gives you the freedom to be able to do that. And if you want a career in programming, this is the place to start because Python is one of the easiest programming languages to learn. Now, you are going to be experiencing nearly 3 hours of free content of this course, the complete Python programming course, which is available on Udemy, normally for $195. But with the coupon that you'll see in the description, you can get it for $10 today. And this will give you access to 8 hours of HD video where you can learn the complete process, even the advanced skills. You will also have access to a paid professional through this course, and it's only $10. But this free video will give you a lot of what you will need to start Python programming. So I hope you really enjoy this. Don't forget to subscribe, leave a like, and drop a comment. Leave us some feedback. Enjoy learning this. This is gonna be a game changer for you.
Welcome all to this Python 3 course. Now, before we begin with the actual course itself, I wanted to go over a few things with you, introduce you to the course a little bit, and explain some of the additional features that we offer along with the course as well. So, the very first thing that you need to take into consideration are the pre-requirements when taking any course out there. We have some very basic pre-requirements for this course. I mean, they are the basic of the basic pre-requirements. You need a functional computer and you need some basic computer skills. You basically need to know how to power your computer on, log in, and from that point onwards, we will guide you through pretty much the whole process. We strive not to skip any steps when explaining anything pretty much. Okay, so another thing that you get with this course and that you get with pretty much any of my courses is the tech support. So if you post in the discussion section, if you have problems with the code, or if you're unable to do something, or you get some sort of errors or something like that, you can always post in the discussion section and somebody will be there to answer your inquiries. Perhaps not me personally, but one of the staff members will come. There are people who are watching those discussion sections, and we will strive to help you out in any way that we can. So if you have a problem, post it in the discussion section first. If it's really that big of a problem and cannot be solved in the discussion section, you can send me a PM. I strive to answer all of the private messages. As a last resort, for whatever reason, if the site is not functional or something like that, you can send me an email. But if you can send me a private message or if you can post in the discussion section, please do so. Email is like the last resort, like really the last resort. But I will strive to answer all of your inquiries. No guarantees there, but we will try. And more often than not, we actually manage to answer all of our questions. Okay, so in addition to that, so to the support and the pre-requirements, we also accept suggestions. So if you're watching the course and if you feel like that certain subjects were not processed or that are missing, or just feel like that you want to learn something about another subject that is related to the course, feel free to send us suggestions. I make no guarantees, but I will read those mails, and if I can squeeze it in time-wise, I will be more than happy to add additional videos. This is not just empty talk. We generally tend to add videos in the courses across the board. So if you have any suggestions, like, okay, I would like this subject to be processed or that subject to be processed, send them. And I will be more than happy to take them into consideration to see if it's actually doable. Can we actually squeeze it into the course? If you have a request for a new course, a particular subject which you would like to be processed, feel free to send those suggestions as well, and we'll see what we can do about that. Another very important matter, feedback. So please leave us an honest review, and when you do leave a review, if you leave a bad review, please write why. So there is a section for that. Everybody can leave feedbacks, everybody that's enrolled in the course, that is. And if you do leave a bad review, please just write why. So you can say perhaps the sound quality was bad, or the video, or the subject was poorly explained, whatever. Make sure to state why. It's very important to us because only then can we actually improve. Some additional resources are my GitHub repositories. You don't need to register or anything like that. You can just get some of the code there. It's pretty much all GPL licensed. And the YouTube channel. So on the YouTube channel, I tend to post some videos that I, for logical reasons, cannot post into the Udemy courses. So for example, if you would like to know, if you are having problems with setting the environment up, the development environment on a Mac or in a Linux or something like that, you can send me a private message or post it in the discussion section and say, hey, Ermin, can you help us out with this? And then I can post a video on YouTube, like, just to help you out. It's completely free. There are no logins that are required or registration or whatever. You just get a link, you click, and you watch, and it helps you out in a sense that your problems get solved. Anyway, that's it. I hope that you do enjoy the course, and I wish you a ton of luck with it.
Hello and welcome to our Python tutorial series. To start off, we're going to show you how to install Python. So it's pretty simple. So you're just going to head on over to your web browser, and we're going to search for download Python. Click the first link, download Python at python.org. So the version we're going to be using in this tutorial is 3.52. You can find it, download it from this when you click this button right here. So you just click that and it automatically gives you a file. You save that. Just wait for the download. So just gotta wait for that. So we're just going to be using 3.5 because you'll notice throughout the series we'll discuss some differences between version 3.52 and the version 2.7, but they're pretty similar, just some minor differences, some arguably pointless differences, but whatever. So we're just gonna wait for this download. It's taking a long time for some reason, I don't know, but anyway, just waiting. So Waiting. Okay, there we go. So we're going to run this file. We're just going to install now. Say yes to all the dialogues. We're just doing express installation. We don't need to tweak with anything. And while that's installing, we're going to just close the browser. We don't need that anymore. So we're just going to wait for this to install. It's pretty simple. You just have to install like any normal executable file in Windows. And we're going to be, after that, after this installs, I'm going to just actually show you something else we're going to need for later when building Python scripts through both the console and in our IDE, which we'll be talking about in the next video. So this is about finished up. There we go. Okay, so now we have Python installed. So when we search for in the start menu py, we have Python. So what we're going to need to add an environmental variable to Windows for Python itself, so we can actually run Python through the Windows command prompt and use it later in our IDE. So first we're going to find the location of Python. So it gives you a shortcut. You're just going to go once again to open file location, and here we have this directory. So we're going to just keep this like this, to set this aside for later. And what we're going to do now, we're going to open the start menu and we're going to search for envi. So if you don't have it automatically for some reason, you can just you just find this PC, the longer way. So you find this PC, you're going to right click and you go to properties and you're going to go to advanced system settings, and here we can close this now. We're going to see environmental variables. So that's what we're looking for. Okay, so down below here, you can see you're going to click this edit, not the one above, the one below. Well, actually, we're going to look for one called path, and then we're going to click edit. Path is capital P and lowercase ath. So here we go. Here are some environmental variables from path, and we're going to add a new one. We're going to create a new one. So we're going to click new, and then we're going to copy this directory. So we're going to copy that. And okay, so new, copy, and that's it. And in case for safe measure, sometimes I'm not sure myself, but I like to add the actual executable files. So we can do the following. Hold on, let me just find let me just take this, and we're just going to say slash, and I'm casting up on the keyboard, so slash python.exe. Yeah, and I believe that checks out. So okay, so just in case we need something, so now everything's set up and ready to go for Python, using Python. And in the next tutorial, we'll actually be showing how to set up our customized IDE, which I hope you tune into. So that pretty much concludes the tutorial. We hope you enjoy this series. Hello, everyone. Before we move on to programming further in Python, we are going to set up our IDE. Now, I like to use Sublime Text. So we're going to open up our web browser and search for Sublime Text to download. So Sublime Text. I'm running on a 64-bit machine, so I use 64-bit. If you're running a 32-bit, just install 32-bit version. So it's downloaded. We're going to download it, and we're going to install it. And you'll notice later that we'll have to manually implement the Python interpreter so we can actually run Python files in Sublime Text. So we're going to install it. All right, close that. It's all finished. Now let's find our Python interpreter path. So when you search for Python in the start menu, open file location, and now for convenience sake, we're going to rename the Python file, the executable file that is, to Python with lower cases. So in my case, it's already done, but if it's different, right click, rename, and type in Python, lowercase. moving on, let's open, so, oops, actually accidentally closed it. So Python, and then you go to your open file location, and then on the shortcut, you see from that search, you do go to properties, and there should be a target field. You're going to want to copy this for later. You're going to save that for later. We'll show you what to do. Just save this for later. So let's open Notepad. So we have this on the side. Just keep a Notepad window open. Just save this path for later. And remember, this is arbitrary. So it could be different on your machine depending on where you installed Python. But on my machine, this is what it is. If you can't see it right now, don't worry. We'll zoom in later. So we're going to minus that. All right, so we have the target. Now let's open Sublime Text. So Sublime. All right, here's Sublime Text. Pretty simple, right? But first, before diving into things, we're going to have to set up the build system, that is. So here it says Python already, but this doesn't work because we tested it and there were some issues with the path. So we're going to manually make a new build system. So you're going to go to Tools, Build System, and then on the bottom you have New Build System like I just did. All right, so here's our new build. It's empty right now. So what we're going to do, we're going to open this. I have this piece of code, this piece of text saved. And you're going to want to copy this exact text, and I'll explain what it is in a sec. So we're going to copy this and paste it into here. And you'll see where our path comes into play. I already have it pasted in here for the sake of time. So you're going to have to paste the path from this file we opened in Notepad. Remember the file we opened in Notepad, we're going to open that and copy it to here. This is the path. And you have to remember that we're in Windows. So we have to use backslashes, and we're using double backslashes because they're escape characters. So be sure to use those double slashes in the path portion of this piece of text for the build. So when we're done, we have this copy pasted and everything, all the path is set. We're going to save this, and then we're going to save it as Python with a capital P, Python dot Sublime dash build. So what this is, we created our own build system. We're going to save. All right, now we have Sublime build. So let's make a Python file. So what we're going to do, we're going to make a new file. We're going to first save as. You don't have to do it like this, but this is how I do it. Save as. And we're going to name it test.py. That's a Python file extension. Oh, and of course, don't forget, if you're automatically inside a folder, go to the desktop for simplicity's sake. So save it as test.py. All right, so here's our Python file. And don't forget to apply the build system itself. So system, as you can see, we added another Python build system. The first one, as I said before, does not work. So here's the build, second one. Choose the second one. All right, so now we should have color coding for functions and stuff. So let's do welcome. So here's our line of code, print in Python. And in order to run this, we're going to do Control B, which is build. And as you can see, welcome printed in the console. And so now we have a full working Python IDE with Sublime Text. That is all for this tutorial. Please tune in next time. Hello everyone. Today we're going to make our very first Python program. To do this, we're going to simply use print. What print does is print a string to the screen. Now inside the parentheses, we pass whatever string or other variables or arguments that we want to print out. As you can see, after writing that statement and pressing enter, it displays welcome to the screen. Now, in older versions of Python, in version 2.7 of Python, the syntax is a little different. This is written like this. Print, no parentheses, welcome. I can't type today, sorry about that. I'll get better, I promise. So as you can see, we wrote with the old syntax, but it didn't work in the new version, as it says missing parentheses in call to print. So that concludes this tutorial. We successfully made our first program where it prints welcome to the screen. I hope you'll join us next time where we'll be talking about data types. Welcome back, everyone. Now we're going to talk about data types. In order to help us illustrate what data types we have, we're going to use the function type. My bad, type. What this function does, it tells the interpreter to output the type of whatever's in the parentheses. So let's start with type 2. What this is integer. An integer is any number, whole number, no decimal points. Let's do type now with 2.2. This is a floating point number. As you can see, there is a decimal point and numbers coming after the decimal point. Let's do a really long integer now. 2 with lots of zeros. In version 2.7, this would be a long integer. However, in version 3.5, this is a regular integer. Let's move on to type of true. If you're familiar with this, this is a Boolean. Boolean is basically true or false, 1 or 0. Now, a specific thing in Python we have is how we deal with characters. My bad. So let's see here. A single character is interpreted as a string. That's because in Python, single characters are considered single-lettered strings. And we'll see the same type come out when we do ABC. It is also a string. So that concludes what data types we're going to be dealing with in Python. Next time we'll be doing variables. Let's talk about variables. If you're not familiar with variables themselves, that's okay. We're here to talk about them. So a variable is basically a reserved memory location with some value in it. So let's write our first variable, number equals 2. All right, so if you've noticed in our previous tutorials, values we've used before are basically gone once they're used. But in the case of number right here, 2 can be reused over and over again. So let's make some more numbers. Variables, my bad. Real word equals, let's say a word. Okay, now let's see how these can be reused. So let's say a word, and we see word. So let's do type of word, and we get class string. So basically we reuse word again and again. Moving on, let's try assigning one value to multiple variables. So let's say A equals B equals C. Now, this is pretty logical as in like in mathematics. You just have multiple variables and you assign one value. So let's demonstrate and see if this works. Print A 1.5, print B 1.5, and print C 1.5. As you can see, this worked. So let's talk about the comma operator now. What this does basically, it can take multiple variables and assign multiple respective values to them. So let's have 1, 2, 3. Those are our 3 variables. And we have 1 as in the number, 2 as in the string, the word, and 3.0 as in 3 in the floating point form. All right, so now we have our variables. And now let's see if this worked. So let's do print 1. We get 1. And print 2. We get 2. And print 3. We should get 3.0. All right. So now let's demonstrate the dynamic nature of variables in Python. So let's reassign number as 1. And then let's make a string called str and inside it string. And then let's say number again, but this time equals string. And if you've noticed, and if you're familiar with other programming languages, this might kind of look weird to you, but in Python, this is kind of unique. It's unique to Python. So basically, you can dynamically assign variables. You don't have to basically first define the type and the variable name to initialize it. In Python, you can just write a string variable name and its value. You don't have to worry about initializing it. And that's what makes Python pretty dynamic. And it's also important to note that variable names should be pretty descriptive, self-descriptive that is. So be sure to name, for example, string. If it's going to be a string, be sure it's pretty logical so you won't get confused later. Like, don't name string if it's a number and number if it's a string. Just be sure that you make variable names that are pretty logical and easy to understand. So moving on, let's see what things we can't give as names in variables. So first we're going to do import keyword and keyword dot kw list. So these are keywords. Basically, they are specific words reserved in Python for specific purposes and functions, like as we saw with print and type. So don't give any names to your variables that are in this list. And that is all for this tutorial on variables. Alright, before moving on and digging deeper into programming in Python, let's talk about the importance of indentation. If you're familiar with other programming languages, blocks of code are separated, for example, in C++ and C with curly braces, and PL and SQL and Pascal use begin and end. Now, in Python, we use indentation, so we basically press the tab key to have a blank empty white space in front of pseudocode here, as we can see. So here we have two functions. We'll talk about functions later, don't worry, in our later tutorial, with pseudocode statements. As you can see here, the indentation separates the blocks of code. As you can see, this statements 1 to 3 are one block, and statements 4 to 5 are another block. So, as you can see, this code is a lot more readable and aesthetically pleasing, unlike before or in other cases where we had jumbled code just all over the place. This is actually, it helps us read it better and it's more organized. And that is all for this tutorial. We'll see you next time. Hello everyone. In this tutorial, we're going to learn how to clear the screen in Python. So first we're going to type out import os, press enter, clear equals lambda colon os dot system in parentheses single quotes cls close parentheses, press enter, and when we use clear every time now, it'll clear the screen. Now, if you're wondering where I got this from, I just looked on the net for clearing the screen in Python. It's pretty simple, and that is all for this tutorial. Hey everyone! Now we're going to talk about comments. So, if you're familiar with comments, what they are, basically, they help us organize our code and tell other programmers what our code does. So, in Python, comments are notated with the hashtag symbol, or if any of you are older generation, the pound key. So when you write this, the hashtag symbol or the pound key, as I might say sometimes, anything afterwards is a comment. So this is a comment. As you can see in Sublime text, it's notated with different colors. So you'll know this is a comment if it's a different color than this. Anyway, so anything after the hashtag is a comment. And this is actually an inline comment. So anything after the hashtag on the same line as that hashtag is going to be a comment. So if we wrote something afterwards, like just random text, see, as you can see, when I write the letters, it's white again. So that's not a comment. But when I add another hashtag, it's going to be comment. And then again, let's do it again. As you can see, comment. And if we run this code, let's do Control B. We're building in Sublime Text. As you can see, we are now working with comments. And the hashtags, anything behind the hashtags are not seen at all. They're not interpreted by Python. So let's erase those. All right. So to recap, they're one line only, and they're written as a hashtag, and anything after the hashtag is a comment. Now, this won't work in the middle of a string, so let's see that. As you can see, it's in the middle of a string and it's not in different color or anything. Let's build that. As you can see, the hashtag is included in this string. So remember, the hashtag must be kept outside of quotations in order to be a comment. And they're inline, so they only work line per line. And that's it. That's all for this tutorial. See you next time. Hello, everyone. Now, segueing from the last tutorial with inline comments, some of you may ask, where are the multi-line comments? Well, in Python, they're written like this. So we're going to use 3 quotation marks. So that's the quotation key, double quote key without the shift. So basically apostrophes, 3 apostrophes. So here you go. So this opens the multi-line comment, and we close it with another 3 quotation marks. As you can see, inside is a bunch of comments. So this opens them, and 3 quotation marks closes them. This is comparable to the /* use characters in other programming languages if you're familiar. So this would open and this would close. This is kind of the same, it has the same functionality. All right, so this can be used to maybe block out a piece of code that you don't, a large piece of code that is, that you don't want to be compiled or interpreted, interpreted in Python, or you want to just write a long string of code of comments. So as you can see, anything comments, let's write some text. All right, so as you can see, there are multiple lines. You don't need multiple hashtags like the last time. It's just everything between this is just comments. So let's build this. And as you can see, the comments are not interpreted. So that concludes this tutorial. We hope to see you next time. Okay, let's continue. So in this chapter, we're going to talk about manipulating numbers in Python. What this means is basically we'll be demonstrating basic mathematical operations, characteristics of dividing numbers, and then we'll talk about advanced arithmetic and operator precedence. But we'll also be talking about manipulation of binary numbers later on. So let's start with basic arithmetic. So we're talking about addition, subtraction, multiplication, and division, which are all simple and intuitive. And the syntax is pretty much similar to other programming languages. So let's start with addition. We're going to do print in order to see our results on the screen. So print 2 plus 5, for example. So this result will be an integer because both operands are an integer. But if we add, for example, 2.2, we'll get 7.2 from this, as you can see. So if there's even one floating point number in the operation, then the result will be a floating point. See, I added 2.0 here. The result now will be 7.0. Moving on to subtraction. So subtraction is going to have a similar thing, similar event going down. So let's do 10 minus 5. And we're going to build that, it's 5. And if we add 10.0 instead of 10, we're going to write 10.0 minus 5, that is, we're going to build and we're going to get 5.0. Moving on to multiplication. This is the same case with multiplication. So let's do 40 times 30. We're going to get 1200. And if we do this times 0.5, we're going to get 600.0 because 0.5 is a floating point number. So let's talk about now an interesting specific thing to Python. That is called the exponent operator, which is basically written as 2 stars. So let's write something out. So we're going to write 2 * 5. This is basically 2 to the power of 5, which is 32. And so in Python, you can't write this with the caret symbol. This won't work. Instead, you should be using, this is actually a binary operator, which we'll see later on. This is using binary logic, which we'll see later on. But what this is called in programming languages is a binary operator because it has two symbols in it, so star star. So as you can see, we will get 32. All right, and that concludes the tutorial on basic arithmetic. We hope to see you next time in our next tutorial. Moving on, let's talk about division characteristics. So, if many of you were wondering from the last tutorial, we didn't talk about division. Well, now we're going to talk about it. So, we're going to write an example. Division is written with the slash key, print, let's do 2 divided by 5, 2 divided by 4, for example. Right, that's division. But as you can see here, we're dealing with integers. And if we build this, we'll get 0.5. So in this version of Python, it automatically interprets it as 0.5. But if we do something like this, for example, let's do 23, let's do, hold on a sec, 23 divided by 5. We get 4.6. So in other older versions of Python, we'll see that this won't return 4.6, rather it will return 4. But in this version, we're dealing with it automatically does it for us. So this is division. Now, so in this case, we don't have to do, in order to get the floating point, we don't have to add a floating point number anymore. So we get the same result. So in this version of Python, it does it automatically. Moving on, let's talk about another binary operator with 2 slashes. What this is, it is the floor division operator. What this does means the result of this division will always be rounded down. You'll get the floor value. So let's build this. As you can see, we got 4. So we forced the values to be rounded down. So even if we do a floating point number, we will get 4 instead of when we do with a single slash, we'll get 4.6. Moving on, let's talk about the modulo operator. What this is you divide and you get the remainder of the division. So let's give an example. Let's do 5 modulo 4. What this will do, it'll give us 1, because 4 goes into 25 6 times, which is 24. 25 minus 24 equals 1. So we get the answer 1. And modulo, the real number, having floating point numbers and everything applies here too. So if we did 25 for modulo 4, we'll get 1.0. We'll get the result as a floating point number. Moving on, let's talk about variables again. So in one of our previous tutorials, our previous tutorial on variables, we can actually save our results of mathematical operations. So let's have variable A equals 2 plus 5. Let's have variable B equals 3.3 times 3. Let's have C equal 10.0 divided by 25. All right, so we have our saved variables. So let's print these out. So we're in our IDE now, so we can write multiple lines of code. And remember, Python does not use semicolons, it works by line. So let's have print, let's do A, and let's do build, and we get 7, which is 2.5. So the result of the mathematical operation was saved to the variable. And let's do the same for B. So we do print B, we get this result floating with the floating point number. And let's do C, and we get 0.4. So that concludes our tutorial. We'll hope to see you next time. Let's talk about operator precedence. So in Python, this kind of works similar to PEMDAS in real mathematics. So the hierarchy goes, the order of precedence, the priority goes parentheses, exponent, multiplication, division, modulo, addition, and subtraction. So let's demonstrate how some of these work. Well, just so you know, in a later tutorial, we'll be talking about parentheses later on in more complex arithmetic. So let's do some mathematical equations. So this following mathematical equation, let's do print in parentheses. Let's do 25 times 15 plus 33 divided by 2.0. This is the same as having A equals 25 times 15, B equals 33 divided by 2.0, and then adding the two together. As you can see, the precedence is 25 minus 5 times 15, my bad, 33 divided by 2.0, and then you add them. So this is basically a simple demonstration of some of the precedents in Python. So let's build that. As you can see, what it did, 25 times 15, 33 divided by 2.0, and we yielded a real number. And then we're also going to demonstrate how this precedence is demonstrated in A equals this expression, B equals that expression, and A plus B. So let's do that, A plus B. We're going to remove this line and then build. As you can see, we have the same result twice. So this is basically the same precedence demonstration as this line of mathematics here. And that concludes this tutorial. So now let's talk about complex arithmetic. This will be done with basically the parentheses. So let's take the example from last time. But this time we're going to add parentheses around a certain part. So we're going to have 25 times 15 plus 33 all divided by 2.0. That's what that means basically. So what this is the same as, this isn't the same as the previous tutorial's example. What this is basically, so we're going to set A equal to 25 times 15 plus 33. So what you can see here is with parentheses, we take even higher precedence. So everything inside the parentheses is taken as one result while still abiding by precedence rules. So this becomes one result, and then this is another result. So everything inside the parentheses is calculated first, and then everything on the outside is calculated then. So this is the same. Let's write this out. We'll demonstrate this. We'll demonstrate that this is not the same as in the previous tutorial. So we're gonna print that, and then we're gonna print A divided by B. And we're gonna build. As you can see, we don't have the same result as last time. We have a different one. All right, so now let's say we have something even more complex. Let me just write this out. So we're gonna have 5.0 times, open more parentheses. As you can see, we're gonna use a lot of parentheses now to show how complex things can get. Minus 2, in parentheses of course, divided by 4 plus 1, all divided by 2. All right, so what we did here is that we are dividing everything we're actually doing operations with different kinds of mathematical formulas. So let's demonstrate this. Hold on, I'm missing a parenthesis somewhere. Just give me a sec. So that's a parentheses. So we do have one around, oh, we're missing an 8. Whoops, I forgot an 8. 8, there we go. And so now we have a bunch of parentheses here. As you can see, there are lots of parentheses. I keep repeating myself here. So parentheses inside parentheses are going to take priority despite the mathematical operations involved. So let's do this. I forgot a parentheses. All right, so this parentheses bunch is going to be calculated, and this one is going to be calculated, and this result is then going to be calculated, and then this is going to be added to 8. And then this whole thing is going to be one result multiplied with 5, and then divided with 2. And then this whole result is going to be modulo 4. We'll write this out, don't worry. So we're going to do A equals 16 minus 2.0. Then we're going to do B equals 4 plus 1. And then we're going to have C, which equals A divided by B. And then we're going to have D equals 8. And then we're going to have E equals D plus C. And then we're going to have F, which is equal to E divided by 2. I'm kind of skipping here some things. I'm kind of mixing it up a little. But this is basically the precedence, how things go. What you could do for E instead is something like this. For example, 8, E is equal to 8 plus C. So an F is equal to E divided by 2, and G is going to be equal to 5.0 times F, my bad. And I made a mistake here. I forgot the equal sign. I forgot one here too. So C equals, not plus. Got my mistake. So G equals 5 times this whole thing. And then we have finally H, which is equal to G modulo 4. So as you can see, the precedence is as follows. So you take the very inner parentheses and you do the operations regardless of the ones of the operations outside. So let's print this out. So let's print the first one, the first line of code. Don't forget to close your parentheses and open the proper ones. And then we're gonna print, print H. As you can see, we got the same result. So these letters demonstrate the precedence with parentheses and complex arithmetic. And this concludes our tutorial. We hope to see you next time. Now let's talk about binary numbers manipulation. In this sort of manipulation, in this operation with binary numbers, we use bitwise operators, which we'll dive into right now. So let's type out the print statement like we always do to display our results. Print. And now our first bitwise operator is the left shift, which is written as less than less than. So the first number on the left is our number to be shifted. And the number on the right after the operator is the amount of places to shift. So this number in binary, let's say we have 5 bits, we have 1. It's going to be shifted to the left 3 times. So 1, 2, 3, which gives us 8 because this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3, which is 8. And as you'll see on the screen below, you'll get 8. Moving on to the right shift operator. It's the same thing, just it works the same way, just it shifts to the right. So let's take two numbers. Our number in question is 32. Remember, this number is converted to binary. So we have 32 in binary shifted 5 places to the right. So we have 6 bits, let's say, and this is 32 with the 6-bit 1, 2, 3, 4, 5, 6. Yep. And then we're going to shift it to the right. So what this result is going to give is 1, 2, 3, 4, 5. It's going to give 1, as you'll see in the build below. As you can see, we got 1. Moving on to our other bitwise operators, the logical ones, AND, OR, and XOR. First, let's talk about AND. AND, what it is, it takes 2 values, and if both are true, then the result is true. So basically, if you have only either 2 ones on either side, then you get 1, as you'll see here. So we have these 2 numbers. Whoops, my bad. I changed the operand. So on both sides now, these are both 2 numbers in binary. So let's write them out in binary. We're not going to build this right now. We're just going to demonstrate how these numbers look like. So 1 with 9 zeros, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 0 with lots of 1s. The rest are 1s. 0 with 9 ones. So when we add this, since none of these are 1, 1, we're just going to get 0. So you compare each one, each bit place. So 0, 1, 0, 1, and so on, 1, 0, all the way to the end. And you get the AND result, which will yield 0 because none of them are 1, 1. So none of these are 1, 1. They're all 1, 0, or 0, 0, or whatever. So as you'll see, the result is 0, which is just 10 zeros. Anyway, moving on. Let's talk about OR. OR is another logical operator where if one side is true, then the rest is all true. At least one side is true, that is. So let's take our number from before. We're going to take our number, but this time we're going to OR it. That's notated with this line. Is shift, on the American keyboards, is shift backslash. It's right under the backspace button usually. Now let's talk about OR operating with OR. So 1, 0 is 1. We have all 1 zeros, so that means we have 1 on every time. So our result will be 511, which is 511, which is basically all these places are going to be 1 now. So that's the result, ORed. Right? Okay, moving on. Let's talk about XOR. XOR is kind of different from AND and OR. It's notated with the caret. And let's actually change the numbers this time to demonstrate it a little better. So 60 XORed with 13. What that's going to give us, let's do that in binary first. So we have 0, 2 zeros, 4 ones, 2 zeros again. And then that's 60. This is 60. And then let's do 13, 4 zeros, 11, 2 ones, 0, 1. All right. So here's our numbers in binary. So XOR, what it does, the two sides must be different in order to yield 1 or true. And if they're not, they yield false, which is 0. All right. So 0, 0, which is 0, 0, 0, which is 0, 1, 0, which is 1, 1, 0, which is 1, 1, 1. They're both the same. So it's 0, 1, 1 again, 0, 0, 0, you get 0 again, and 0, 1, you get 1. And this number should be 49. We'll test it out right now. As you can see, we built it, and we got 49. So that concludes this tutorial on bitwise operators. We hope to see you next time. Now let's talk about if statements. If statements are used together with conditions to determine which part of the code will be executed next if the evaluated condition is true. Think of this as a sort of conversation between two people. So let's make a variable called passerby speech, just like in a normal conversation. We're going to set this equal to hello. And now we're going to check this. Oops, I made a typo with a G, excuse me. All right, so let's make our if statement. So we're going to start with writing if. Then we're going to write our variable. As you can see in Sublime Text, we have autofill, which is a miracle, kind of. It makes our life a lot easier when programming in Sublime Text. Writing programs, excuse me. So if passerby speech equals hello, which it does, or we're going to, as you can see the or and a logical operator and our conditional operator used before. So we're using these in if statements. All right, so hello is if passerby speech equals hello, or if passerby speech equals hi. As you can see, they're both two greetings. The result is going to be print hi, how are you? All right, so basically this is illustrating a normal greeting. So if someone says hi to you, well, depending on who you are, you just say hi back and how are you. So let's build this. As you can see, there is a syntax error here, so let me just check my syntax. I believe it is the indentation. Oh, no. As you can see here, this is a common mistake sometimes with programmers. What they do, you have to make a double equal sign and not just a single one, because in if statements, this is actual condition. So be sure to memorize that. And this is in a declaration of a variable and setting it equal to a value. So just remember, in if statements and conditions, use the double equal sign. All right, so let's build it. And there's a hi, which is something. Oh, in Python, we also have to add a colon in the if statement. I forgot to add that colon before. So let's build it now. As you can see, since passerby speech equals hello, which yields true in this if statement, we get hi, how are you? So anything within the if statement is processed when the result of this condition is true. All right, moving on. So as you can see, let's just write our if statement formula sort of. So we have if, we have a condition, and then we have to indent. Remember, indentation in Python is very important. So anything indented. Oh, and of course, again, I forgot the colon. So we have condition, let's say statement, colon, and then anything after that indented is within that if statement when that condition is true. So we have some code here. Let's just write some comments, code, and we just have some pseudocode like print and so on. So this is just how our if statement works. So we write if, our condition, then a colon, and then after that we use indentation to sort of contain whatever to interpret whatever code is to be executed when we have the condition equal to true. So to recap, just remember that indentation in if statements, like in most of Python, is very important. So like this, let's write something. If, just some pseudocode, if true, colon, and we didn't indent, print test. This is not the right way to write an if statement, so we're going to need indentation here. And that is all for this tutorial. We hope you tune in next time. To conclude this chapter, we're going to discuss the break and the continue statements. First, let's start off with break. Okay, so what break is going to do, it is used when we want to stop an execution of a loop. So from the previous tutorial, we had this infinite loop where it printed an infinite amount of times. And when we use break, for example, let's write out break, and then we're going to print. As you can see, it only printed out once. So after printing, it broke the loop and it finished, and it only printed infinite once. And that's pretty much how break works. So if you want to stop a loop, just use break. Like you could have a condition, another condition within the while loop, and after that condition, it breaks. So let's talk about continue now. So we're going to erase that. And if you want to skip a certain step in the execution of a loop, we use continue. This command, what it does, it skips all the commands that come after continue all the way to the end of the loop. So let's write, and it's used often in for loops. So let's write for, it kind of filled it out already when you press tab in Sublime text, but don't worry about that. Let's just write out what we need. So we're going to do 1 to 11, and then we're going to have if I equals 5, colon, we're going to do continue. So what this does, it skips print, and of course at the end we're going to have print. What this is going to do is it's going to skip where I equals 5. So let's do that. Let's print that out. Let's build that, and let's see our result. As you can see, there's no 5 here because when we use continue on the condition if I equals 5, excuse me, we don't print it out, we just skip it. And so that's pretty much break and continue. That's pretty much it. We hope to see you next time. Welcome back. In this chapter, we'll be talking about functions in Python. We'll be learning where to use functions, how to define them, and how to pass parameters. And we'll also conclude this chapter with the lambda functions. To start off, we're going to talk about something which is called decomposition. So what that is basically segmenting the code into smaller parts, mostly for easier reading and maintenance. And we'll basically be using this for functions, which are portions of code that are set out to do a certain task or to return a certain result. So let's start off by defining our first function right here. So let's go here. And so in Python, we start off with def, which is sort of a built-in kind of function as you saw here. Def, and then we're going to have our name of a function. Let's just call it function for now. In Sublime text, you know you did it right, but when you have different colored text for the name of the function. And then you add parentheses, and then you add a colon. And then you indent, and then you add whatever code this function is supposed to carry out, what portion of the tasks this function is going to do. So for example, this is going to print, this is our first function. Okay, so this function is sort of code within the code, so it's a portion of the full program that does just printing out this statement. And now we can call this function. So we call, if you're familiar with other programming languages, later on we can reuse this function by calling it in the following way. So you type the name of the function in Sublime text. We have autofill, so we're going to function, parentheses, and that's pretty much it. And then when we build this, as you can see, we have our predefined function, and then we call it, and that code is read by the interpreter, and you see your results here. So what we also have with functions is returning results. This is another service purpose of functions. And what this does, instead of having basically this print inside the function, we actually have a return value, which is another purpose of functions, to give a return value of some sort of code that's to be carried out, that is to be read and interpreted. So let's do this. Let's define another function, def, and the name of this function, let's say it's called, I don't know, returning, parentheses, and then colon, and then inside that we're going to have return a string, for example, and let's say I am a result. Okay, so in this case, since we have return, it won't print out. This returns a value, but you have to print it out manually. So let's do this. So we have print, and inside that we're going to have returning. As you can see, it autofills for us. So returning, don't forget your parentheses. So as you can see here, returning, and there you go. And a good habit to have when programming is that you store return functions with the return value to a variable of some sort. So let's say we have a variable called result equals to, and we're going to call returning with parentheses, don't forget, and then we print out the variable result. As you can see, it's the same thing, but this time it looks more orderly and clean instead of having it the way we had it before, which is like function within a function with like double parentheses, and that's kind of confusing. So like this, it's pretty clean. And moving on, we also have something interesting in Python, which is we can return multiple values. So let's make another function. So def, and we're going to say we're going to call this one, I don't know, let's say multival. Open our parentheses, colon, and then we're going to say, so return, and then let's say we have two values, a string called this is a result, and then to separate them we have a comma, let me fix the string. We have a comma, and it's separated by the other value. So as you can see here, we have two values, and they're separated by the comma. And notice that this function is printed out in parentheses, which you're going to see right now. So let's do this. We're just going to do it the messy way. So let's do print multival, and let's print build that. As you can see, it's sort of, here's our first return value, and here's our second. And so that's it. This is how they're separated. And then later we'll learn how to actually extract these values. And that pretty much concludes our introduction to functions. Please tune in next time. Hello everyone. In this chapter we'll be talking about exceptions and how to handle them. We'll learn about what exceptions are and how to basically handle such exceptions. I keep repeating myself with handling exceptions and errors in Python. And then on the end, we'll also learn how to create we'll learn how to create our own exceptions in Python. So to start off, we'll be defining what an exception is exactly. So what it is basically an error that occurs when a program during its execution is run into a situation that is not defined. So that's kind of like a kind of textbook answer. So let's just demonstrate what that looks like. So let's print the following. Print 5 divided by 0. Well, obviously that's undefined because anything divided by 0 is undefined. So let's build that. Control B. All right, so here we go. And here's the exception. Zero division error, division by 0. So as you know, like I just said, I keep repeating myself that this is an exception, and it is undefined because dividing by 0 is undefined. So that's basically this. It's zero division error. And then we also have that, if you remember, we worked with, from our previous tutorial, you can watch that too, about working with file management. We also have the following error. If we have want to open a file that doesn't exist, so let's say open, and the file is called, I don't know, let's just call it file, just random, and then we want to see in read mode. But what's going to happen is the following. You get the following file not found error. So that's another error. So we can this also occurs when we want to convert. We also have another error where when we want to convert a string into an integer. So let's do the following. We have int, and then we have 1.2. And then B, and as you can see, value error because 1.2 isn't actually an integer. It's a floating point number, with a decimal point after. There's a number after the decimal point. All right. Now, if we type out the two following lines, so let's do that right now. So let's say A equals A equals 5 divided by 0. And then we say print after error. So let's say we have that. Let's do this. As you can see, it'll identify actually where the error occurred. So as you can see here, it says trace back most recent call last, blah, 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 line 2. It says where the error occurred. So, and it identifies which error actually occurred. So now that we've introduced ourselves to exceptions and errors, we'll try how to learn them and to avoid such situations with these errors. But keep in mind that these errors do not happen very often, but a good programmer will make sure they're handled and dealt with beforehand. And that pretty much concludes this tutorial. See you next time. So now let's talk about data input. So what data input basically is the user inputting some sort of data and getting some reply back from the console or the system. It does like some sort of calculation or manipulation of the input data and returns some sort of output. So this is done with the following two functions. We have both input and raw input functions. Now the difference between the two, so I have some code right here we're going to work with later. input itself is it's the current on the current version Python 3. It's used for input and for prompting the user to input some sort of string and getting a reply back of the string. In the older version of Python, like in Python version 2, we have raw input. And in version 3, this doesn't work anymore because they completely removed it. So now we just have input. So before I continue, we're going to have to set up how to allow Sublime Text to have like sort of console input, because like as it is, when we build it, it doesn't work as it should. As you can see, it prints out the the prompt string, but it doesn't do anything. So what we're going to do, we're going to first show you how to actually enable console input, data input in Python through version. This is Sublime 3, Sublime Text 3. So what we're going to do, first we got to install this package control. And what I did, you just go to Google and let me open this. And thanks to our friends at packagecontrol.io, they provide everything for us, and we just download the package control Sublime Text package, and of course you download it, and then you have to find a directory for Sublime Text. So let's find that right now. And in my case, it's 64-bit, so it's in program files. And under Sublime Text 3, there's a packages folder, and here I already have it placed, but here, as you can see, I'll just drag it in for you. So let's see. Okay, so here we go. We open the containing folder, and it's in downloads, of course. Then we're just gonna drag it into our Sublime Text directory. So whoops, I accidentally skipped. So here we go. You just copy that. And that's pretty much it. And then once you have that installed, you have to restart Sublime Text. So you're going to close that. And then we're going to come back. So let's open up Sublime Text again. Okay, so now we're going to have this thing called Sublime Reply, REPL, under the Tools tab. What this is, it's going to allow us to set up console input for Python. So you go under Sublime RPL, and then we have the Python subtab, and then we're going to have to choose Python run current file. But when we click it, it says file found error. So in order to fix this, we're going to do the following. We have to basically add an environment variable in Windows. So what we're going to do, we're going to have to head over to our system properties. This is done by finding your PC. So this PC in my case, and you go to properties of your system. And then you have advanced system settings. And over here in the advanced system settings, you have environment variables. And then on the lower part where it says system variables, you're going to click on the path variable. And here you have a bunch of various options, and we're going to have to add a new one right now. So we're going to click on new, but before doing that, we're going to have to find the path, the path of Python wherever it's installed. So we're going to find that right now. Just a shortcut way, we're just going to search for Python here, Python, as you can see, and then we're going to go to open file location, and this in my case is a shortcut, so you do the same thing again, open file location, and here it is. And then up here in Windows Explorer, you just click on the search bar, copy this whole address, this path, copy that, you can close it, and then when you add new environment variable, you paste it. Okay, it should be added now. You can close this. And then we're going to restart Sublime Text. So close that. And then we're going to open Sublime Text again. I should really put a shortcut on the desktop. All right, so now here's our code again. So what we're going to do this time, instead of doing Control B or building it, we're going to go to Sublime Reply, go under Python, and then run. And as you can see, this is a new sort of console and gives us the prompt. And when I write the answer 20, it echoes our reply. And that's pretty much it. So now you're set up to do console data input in Sublime Text. So remember, don't build. You have to actually go here, Sublime Reply, and go to Python and run current file. And that pretty much concludes this introduction. We hope to see you next time. Now let's talk about file management. To start off, we're going to learn about how to open a file. So first, we're going to start off by making a variable called file, and then we're going to equals to the function called open. So before I move on, I'm going to just talk about how the prototype open and what it's supposed to look like. So let's make this a comment. Open, the parameters go in the following way. So we have the file name, then we have the access mode, which can be read or write or both. So access, or let's just say, to keep it simple, actually, just say read or write. Excuse me. And then we have an optional one, which is buffering. That's basically telling us whether buffering will be used. And we might talk about later, but our focus is file name and access. So let's open our first file. So we have our first parameter, and then in my case, I'm using a direct path. If you don't use a path, it'll open this file in wherever your Sublime full text project is located. So in my case, I'm using the path, and if you're using the slashes, don't forget to use escape characters where you have to try it in the slash twice. So we have our file, then we're going to have comma, and then the mode. And we're going to say R for read. Okay, so now we're going to print what we're reading from the file. What we're going to do with this function we're going to have is read. That's basically it reads from the file. So we opened it, and now we're going to read from it. So we're going to print that out, and then we have file.read. Don't forget your parentheses. It's a method, so don't forget your parentheses, that's all. All right, so we're going to build that. As you can see, in my file, I wrote hello, so that's it. And then a good practice to have, so when you're done with the file, you close it. Now the method close looks like this, close with parentheses. And then we're going to we do file.close. So basically we use the variable because it's a lot easier. It's basically proper code etiquette. So we have a variable for where we open the file. And then every time we need to work with a file, we have the variable name of where the file is, dot, and the method. So we closed it, and there you go. All right, moving on. What we can do, we can read a specific amount of characters in a file. So the parameter in read is as follows. So let's say we have 4. That means that's the number of bytes to be read. So that's approximated to every amount of characters. So let's say we're going to read 4 bytes or 4 characters from the file. So when I do that, hello has 5 letters, and now we're only reading 4 letters. And so that's pretty much it for read. So let's move on to another function called tell. What tell is going to do, it tells us where the current position of the pointer is in the file. So let's say we have our current code, and we're going to print, don't forget, file dot tell, and we're going to print, and what it says, our cursor is at the 4th position right now. So if we change this to 5, it goes to 5. All right, so we mentioned the pointer. So this is indicates where we're currently reading from the file. So we have another function called seek. What this does, it allows us to move the pointer within the file to wherever we need to for whatever purpose. So let me just talk about the arguments, parameters first. So the first one is the number of bytes for which we want to actually move the pointer. And the other one's optional, so we won't be talking about it too much. So we have seek file.seek. And let's say we want to, so let's take our previous example. So we take this, we have file seek. Let's just clean this up a little. Okay, so let's say we're reading 4 characters. And then afterwards, we want to go to the end of the file anyway. So for just some purpose. So we're going to do file seek, and then at the end, we're going to do file tell. And then we're going to build that. Oh, I forgot to print, of course. So print. And there we go. That should work. Yes. So before, if we take this out, it would have been 4. But now we have 5 because we moved the cursor to the end of the file. And that pretty much illustrates how that works. So what we can also do, we can read, let's get rid of all this. We're not going to need this right now. All right, what we can also do, we can also read the file one line at a time by using a loop. So for line in, so we can actually use loops with the file itself. So let's say you have a bunch of text. So let me just write this out first, and then we have line. So this is going to read line per line, and of course, after we're done, we're going to file close. All right, so let me just go back to my file, and we're going to add some lines. Line. So let's just copy a bunch of line. All right, so we have hello and then a bunch, 4 lines. All right, so let's print this out. Oops, and I forgot something. Hold on a sec. File close. Okay, so in file, let me just check my syntax. I forgot the colon again. All right, so there you go. It used the for loop to print every single line, because if we just did print line, it would just do 1 line, or just print file would do 1 line until the end character. So in this case, it printed every single line. And then you just close it, as we usually do in proper practice. And so now what we can also talk about is so when working with files, we should basically know get to know some attributes. So let's do the following. So we have print, so let's say file name. We're going to just get to know some attributes. So file name, and that's going to be plus, we're adding to the string file dot name. Then we have print is closed. And then we're going to do string function, so display the string of file closed. And then we have print, and then we're going to print the mode that we're in. So you might need these might prove to be useful later on in whatever programming jobs you have. So, whoops, I made a mistake somewhere. Where is it? Oh no, here we go. All right, so it printed out basically what we had in here. So we might need this first. This stuff might come in handy, these attributes, for whatever you're doing. So we returned the file name. We returned whether it's closed or not. So we said it returns a bool. So we want to typecast it as a string. So we said, give me the string. Is it true or false? So is it closed? No, because we just opened it. So, and then we asked for the mode, and I made here mode L, here mode R, and that's pretty much it. So that concludes file reading. Next time we'll be dealing with file writing. To conclude this chapter, we're going to talk about writing to a file. So first we need to write the file with appropriate permission. Now we have, so first we're going to start off with starting with file equals. This time we're going to open this time. However, we're going to use the mode W plus. This means we can read and write with this file. Opens the file for both reading and writing. We also have something called WB, which opens the file in binary format. But we won't be using that, so we're going to be using W plus, so reading and writing, to demonstrate how this works. Now, when you open a file in write mode, it's going to overwrite the existing file, or if it doesn't exist, it'll create a new file. So let's make a new file called write.txt. And this is stored in wherever the Sublime text project is located inside that folder. So we're going to open a file called write.txt, which we're going to use for reading and writing. So let's do the following. So we're going to do write. We have the method called write. And the argument inside that is the parameter inside that is going to be the string that whatever we're going to write to the file. So we have hello file. I am string. So we have that written. So let's say we want to read what we just wrote now. So once we write to a file, the pointer in the file is moved to the very end. So we want to get it back to the beginning. The pointer, back to the beginning. So we're going to use file.seek and then 0 to go back to the very beginning of the file. So we can actually, go back to the beginning. All right, so then we're going to print file.read, and then afterwards we're going to close as part of good practice. We're going to close. As you can see, it did it. Now if we removed seek, let's do remove seek. As you can see, there's nothing there because we're at the end of the file. So yeah, that's pretty much that. And then what we can also do, let's do fseek, file seek back to the end, and we can basically write within that. So let's say once we use seek, we can write at that position. So at the very beginning of the file, we're going to write a new string as a part of the whole text inside the file. So let's do write. And then from that write, we're going to say this. And then we're going to build. And as you can see, it did it from that. It started from that position. So let's use seek again. So it wrote this, and then after writing it, it went to the very end of that position. So let's do this. And it basically overwrote whatever was here. So it wrote the hell and hello with this because we were at the beginning, so it took 4 characters and rewrote them. And that pretty much concludes the chapter dealing with data input and file management. We hope to see you next time. So now let's talk about another data type called dictionaries. A data structure, called dictionaries. Dictionaries are basically collections of key value pairs. So I'll show you what that looks like. So we have key value pairs. And they are known as maps or associative arrays. So each key has a value. And every key is unique. And values don't really necessarily have to be unique. So let's write out our first example of a dictionary. So we're going to call this my dictionary equals. And in this data structure, we use curly braces. And then we define our key. So here's our key. And then we have we have key, the key itself, then a semicolon, and then value. and then each pair is separated by a comma. So a key and keys and values can be any type. You can associate them with any data type, anything really. It could be anything you want, and you should define a base depending on your task given to you. So we can have a tuple, for example. You could have a number. You could have whatever. Really anything, and you'll see the results when I print them out. So you have the key and you have the value. And you also have another way of defining a dictionary by using a for loop in the dictionary. So you open your curly braces, and then you write out whatever you need. So let's do this following example. So we have key x, and we have the value x plus 1, and then we have a for loop for x in range 10. And then we're going to print these out. Print my dictionary. There you go. There you go. All right. And here's an error, a comma again. All right. So here you go. And keep in mind, sometimes when it prints out the dictionary, it'll be sometimes it'll be in different orders. You'll see in a minute when we add a pair to a dictionary, it'll sometimes be added on the end or added on the beginning. So, but anyway, so this is basically how you print one out, print dictionaries out. And the indexes, instead of using indexes, we use the actual key. So if we want to get the key from a value with this key, we open our square brackets with the name of the dictionary, and we type in the key. As you can see, key is associated with value, so we got value. All right, and if we try to access an element that is not in a dictionary, we'll get a number error. So let's do the following. So we're going to, I think we can erase this, yeah. So we're going to do try. So we're going to do some error handling here, exception handling. So let's do print, and then we're going to do my dictionary. The first one we made, my dictionary with key 1. And then we're going to do except, and then we're going to make our exception as E, and then we're going to print that exception. See what happens. As you can see, we got a 1. And like I said, you just get a number error. Okay, so what we're going to do next is we're just going to basically, there's two functions we have. If you want to separately display keys and values, you have the following functions. So you have keys and you have values. It looks like that. So you're going to we're going to print my dictionary dot keys, and then we get only the keys from the dictionary. And if we want it to do print, we're going to get my dictionary dot values to get only the values, all of them in that dictionary. So we got key, the tuple key, and we got value 5 for values. So, and next, if you want to add an element to a dictionary, we do it in the following way. So let's remove this. We're going to take this away. My keyboard's acting up. Anyway, so what we're going to do, we're going to take my dictionary, open our square brackets, and add a new key. And then we're going to set it equal to the value we want to assign. And when we build, as you can see, it's sometimes in random places, but we still got the new key. We got the new key value pair. And if we want to change an existing key value of an existing key, you take the key. So we have 1. Here's our 1, and then we're going to say equal to 3. As you can see here, it changed to 3. All right. So, and when you want to delete a specified key, you take the following. So we made this, and then we're going to say, okay, let me delete that now. So we do del, it's a keyword, and then we take the dictionary, and we basically open our square brackets and have the desired key we want to delete. As you can see, the one we made here is gone. And so we see that change applied to one object also applies to the other one. And if we don't want this to happen, so we have to create a deep copy of the object. But we will learn how to do this in the following chapters. So don't worry about like anything, if any bigger ideas with changing multiple objects. So anyway, moving on. If you want to remove all elements from a dictionary, it's a new function it's called clear. So you have my dictionary and you have clear. And you print it out and you see it's empty. And that pretty much concludes the basics with dictionaries. Tune in next time. Hello everyone. So now we're going to move on to modules and packages. So what they do, they serve to break down big programs into smaller logical units. And if you remember from one of our previous tutorials, we talked about decompositions of programs, and this is just that. So we can think of modules as a way of program decomposition on the file level, because we'll have different we'll be importing files, as you'll see later on. So what they enable us to do is they enable us to reuse code in these modules for later. So you don't have to write a function keep repeating writing an existing function and stuff like that. So anyway, let's move on. So to keep things brief, I wrote things ahead of time. So here's our module. It contains functions. It's another Python file contains functions. So, and be sure to have them in the same place as your other Python file. The module should be in the same file as the same location. So here in my case it's on the desktop, but it could be anywhere, like in a project folder or whatever. Anyway, so since we have that in the same folder, we're going to import. Use the keyword import. As you can see, it's highlighted, which means the keyword. So from that, we do import and we do the name of that file. No, you don't have to do .py like .python. You just do import prime. And when we use this, we have access to all the functions in this module, in this file. So primes to, I mean, there's no autofill here, but it still works. And we have a parameter. As you can see, the function worked, and that's this function right here. So moving on, we can also actually import a function with an alias. So what an alias is basically just a different name of a file or whatever, anything really, and we'll name it PR. So it's easier to type out instead of writing prime all the time. You might get lazy, or if the file name is actually really long and you just want to have like a simple letter or whatever. As you can see, it did the same thing. Anyway, moving on, we could also, so let's say we can also just import a function from a module. So if you just need a function and not the whole module itself, you just do the following. So we're going to say from, you start off with from, it's a keyword, module name, import keyword, and then the function you want. We're going to do primes2. And now you just write the function out, primes2. And then you can do the same thing. And there you go. And what you can also do, a use of function for modules, is the dir function. We'll just call it dir or dir. This function. What this does, it takes your parameter, the module, as a parameter, and returns all functions that are defined in the module. So we have dir, we have to import, don't forget to import prime, and then we're going to say dir prime. We're going to build. Oh, don't forget you got to print it as well. There you go. And so in the next tutorial, we'll be explaining, because this kind of piggybacks into packages. So we'll talk about these results in the next tutorial. So tune in next time. So now we'll briefly talk about and explain what packages are and how to create them. So to create a package, we copy all the modules that should be in a package into one folder. So basically, a package can be treated as a folder, but with a special file, that's a special Python file with the following. So you have this, it looks like this. So 3 underscores, so underscore, 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 init, and then init, and then 2 underscores, and that's the name of the new Python file. So this basically treats a folder as a package. So let's make one of those folders right now. So a package can contain several modules, which are basically files that can be used when you import the whole package instead of importing multiple modules. So let's call this main. And first, we're just going to copy this on over. Rename it to that. There you go. Okay, so now this main folder is a package. And you could also have sub-packages too, so folders within folders with this file. So new, you just make a new folder. There you go. Copy, and then, so make sure you have this file, the initializing file inside each folder, and then you have a sub-package. You just make 2 of them, rename them. And be sure the whole package folder is inside the same directory as your Python file. Alright, so there you go. And you know what, for the sake of the tutorial, we'll also have prime, the module prime from last time, inside one of the sub-packages, so we can demonstrate how they work. Alright, so there you go, package is ready, it's called main. So now we import the package. What we do, you do import the main package's name, and for sub-packages, for layered sub-packages, you do the following. So sub, and the hierarchy is by dot. So main sub2 dot module. So our module is called prime, right? And then you have to use an alias in this case. So as sub2. All right, so now when we do sub2 dot primes2, the function from our module we used from last time, and there you go. We get the function. We get this function and everything works out, checks out here. And so and you could also do the same with a single function like from before, but this time we're using packages, of course. We have from, then you do the same, the import from main sub2 dot prime, and we just want the function, for example, import the function name, which is primes2, and then you just write primes2, and that's pretty much it. So that's pretty much how packages work, and that concludes this tutorial. So now that we've talked about making our own modules, we're going to talk about built-in modules. So in this example, we'll be dealing with the shallow copy problem, which is used in dictionaries, data structures in general. So what a shallow copy is basically when you copy an object, or like for example a dictionary, those two, the new copy and the original copy, will share individual values. So, but what we're going to do now is make a deep copy, which is basically when you copy a dictionary, for example, the new copy of the dictionary will have its own set, it'll have everything duplicated. So each one they'll be the same initially, but they'll be duplicated. So let's jump right into it. Okay, so now this built-in module is called copy. So here's what it looks like. So import copy. Alright, so let's make a dictionary, my dictionary. equals, and now we're gonna have some from, if you remember from last time, so key value, we have our key value pairs like we said before, separated by the comma, and then we're gonna have our tuple key k e y, let's make it capital Y, and then colon 5. Alright, so now we're gonna make, well, instead of copying it, we're gonna do, it's gonna look like this. So we have copy dot deep copy, and then the parameter is your dictionary data structure, my dictionary. Alright, so this is a built-in module, and it creates a deep copy using the function with this built-in module. Alright, so now to make some difference, we're just gonna add my dictionary. We're gonna do this code right here just to make a little difference. We're gonna add the key pair 1 1. Alright, so let's print them out and you'll see how this built-in module works. So my dictionary, this name is my dictionary 1, my dictionary, and then my dictionary 1. Alright, build. Here we go. Oops, I made it. There we go. So, as you can see, it copied everything, duplicated every single thing. But just to make a difference, I added in the first one 1 1 pair. So another module we have is math, the math module. It's built in, so when you import and do math, you'll have a lot of mathematical functions like cosine, exponent, ceiling, and we'll do those right now. So we can delete all this, we don't need dictionaries anymore. So let's print, and then, you could alias this, you don't have to, because it's short, so math as m, and then we're going to do m dot cos for cosine, and then you have pi in the module, so that should work. So cosine of pi is -1. And then you have the exponent, let's do this, exp, and then 1, and you get e, so exponent is e to the power of whatever, so e to the power of 2, for example, is that, and so on. And you have ceiling, which if I might have talked about it before, but it rounds up, so ceiling of 1.6 is 2. And you also have a complex number module, so it's called cmath, so we can do that too. So import cmath as cm, and what you can do with this, let's find out. Let's do dir, if you remember that from cm. We're going to print that. As you can see, it shows everything, all of the functions, all the modules we have in this package. Anyway, in this we have all the functions we have in this module, excuse me. And then so we can use something like square root. So square root. We're just explaining all of the maybe the useful functions you need. And I forgot the numbers. Let's say 4, 2, and it shows that as a complex number here. So as you can see, plus 0j. And we could also do polar in the following way. So let's do that. Might be useful for some of you. And we're gonna say, so we have a complex function 2. There you go, 0, 0. And wait, forgot something. Forgot our parameters. 0, 1. And there you go. There's that. And we also have a random module, which is called import. It's called random as r. Let's call it ran. And what you can do, you can generate random numbers with this one. But let's see what dir ran build, and you have all these functions in there. So in this module, you can generate random numbers using different functions. For example, you have sample. Let's see, you have ran.sample, which generates a random sample of 3 elements. So we have the parameter like a list, for example. We have, here we go, 5, and then we have 3. Oops, I made a mistake. Hold on. Ran sample. I forgot something. Parentheses. And there you go. It took a random. See, it goes randomly. We also have random, which uniformly generates a random number from an interval. So random. I don't think we need this. Here we go. Just get some parentheses in there. All right, so generates a random number from 0 to 1. So let's say 10. Oops. But yeah, so it generates a random 0. So if you want to do like 10, for example, you do parentheses 10, up to 10. This is up to 1, basically, so from 0 to 1. Let's try 100. So as you can see, it just returns 0 from interval 0 to 1. Now, you have an interval option variation of this, so random. So you do rand int. So it makes a random interval from interval 5 to 100, for example. And this, what this does, gets a random number from that interval. So one more module we have is the sys module, sys. So let's import that. So import sys. I don't think we need to make an alias for that. So now let's do something with this. So what this does, this module gives us information on constants and functions that are related to the Python interpreter. So for example, you can get information on the max depth of recursion. So let's see that. So we have print sys dot get recursion limit. Go, and you have 1000. So you can have recursion up to 1000 times. You also have print sys version, where we can see. Hold on, what's this? Oh, right. There we go. And it tells us the version of our Python, what Python interpreter we're using. So mine is 3.51. We also have path, which shows us where all of the modules are. So this module, the sys module, allows us to pass arguments from the console when executing the script, which you can see in the following. Just let me get this file, prime test. You can see how it's used here in a module I made before. So you have it here being used. So it takes one argument from the console, the first argument, when you press enter, and it takes one argument from the console when you run this module in the console. And that's pretty much it for this chapter. We hope to see you next time. Alright, so in this chapter we're going to be talking about something that's sort of advanced in programming. It's called Object-Oriented Programming, or OOP for short. So in this tutorial we're just going to basically talk about the basic concepts and principles of OOP and what it is used, how it's used and why. And so we'll just basically talk about the whole idea behind OOP. So the whole idea behind it is basically to create a class that contains descriptions, definitions, and all possible actions that can be performed on data. So these defined actions are basically called methods or functions. I'll be using methods more often than functions because in OOP we like to use methods more. And so keep in mind that once you write a class and define all of its methods, you can only use defined methods when working with data. So you can't have basically anything random. Everything's predefined. So when talking about OOP, it is important to mention these 4 basic principles. So we have the following. We have hiding. So we're going to have hiding information. We're going to have encapsulation. And then we're also going to have inheritance. And last but not least, polymorphism. So what hiding info is, so basically what this means is that a user does not need to know how the class is implemented. They just need to know what the class can do, and so or what that is basically is what methods are defined in the class and what its purpose is. So there is no need to show implementation of class instances. And it's good to note that an instance of a class is a variable that is of the class's type. And so we have encapsulation, which basically means that all variables, basically instances, and methods are logically grouped together. So you won't have everything random. You'll see later on that we'll basically make it with cars, for example, vehicle. A car is a vehicle, a truck is a vehicle, and so on. And then we'll also talk about inheritance and polymorphisms at a later time because they're more kind of complicated. So it's basically impossible to explain all these things at once, so we'll learn about these things in examples. So this will be an example-focused tutorial kind of chapter. So keep in mind that some of you will find this topic kind of difficult, but that's okay because it's all programmers should basically. It's recommended for everyone, all programmers, to explore this topic in detail, and also the discussion section is there for you if you have any questions. So that's basically it for this introduction. So just tune in next time and we'll be on our way with object-oriented programming. Alright, so let's dive into object-oriented programming. So to start off, we're going to define what a class is. So a class is a collection of attributes that are defined for any object, as I wrote up here. And so each class has attributes which include data members, which are the class and instance variables, and methods. So to actually define a class, the syntax is written as follows. So you have class, and then you also have the name. As you can see, everything's highlighted in Sublime text. So, and then after that, we have something called the docstring, which is basically a short description of the class itself. So this is just going to say desk, like that, and there you go. And then after that, you have the body. So we're going to actually illustrate how this all works with actually an example itself. So we're going to simulate complex numbers with the class. So we're going to define a class, call it complex, and then we're going to have our docstring. This class simulates complex numbers. There you go. And then we're going to have our constructor. So our constructor method. So it's written the following way. So we have def, 2 underscores, init, 2 other more underscores, and then we're going to have 3 attributes, self, real, and imag. So we have our real and imaginary parts. And what this method does, it creates new instances. So keep in mind that class methods are created in the same way as regular ones. However, the only difference is that we have this self argument here, which is always placed first in our argument list. So after this, we're going to add our colon, and then we're going to write the following. So self.real equals real, and we're going to have self.imag equals imaginary. So imag. So these represent our real imaginary parts respectively. So these attributes are instance variables. Instance variables are defined by self dot whatever the name is. So this is an instant variable itself. So we can conclude that this real and self.real are not the same thing. And the same thing goes for the imaginary part as well. What this is actually this is the instance variable, and this is the constructor argument. So now that we've done this, we want to, let's say we want to create an instance of our class. So we have our variable and we set it equal to the type, the class itself. So as you can see, it auto-filled to our class's name, and we define our arguments. So we want to have the imaginary part and the real part equal to 1. So, and then when we want to print this out or access these values, we do, for example, we want to print, we have c.real, comma, c.imag. So we're accessing these values directly. And hold on, I made a mistake somewhere. Here we go, just let me check. Complex, line 13. So, what is it? What is going on here? Oh, right. I forgot something up here. Why is it giving me an error? Attribute error object has no attribute. Oh, that's of course. I did, I have a minus here instead. Okay, there we go. Sorry about that. So upon defining a constructor, we pass the arguments like we just did. And this includes, so self, we use self, we're actually using self here. So when we want to pass values in our arguments, we're basically passing self and the other arguments themselves. So we're actually passing 3 here. So what we're going to do now is, let's say we assume we want to instantiate a complex number where we only care about the real component of that number. So let's say we have 2. As you can see, it got an error. So what we like to do, good practice, is for the interpreter's sake, we use try and catch statements. So we're going to try 2, and then we're going to say except exception as colon, and then we're going to say print re. As you can see, wait, hold on, C complex. Oh, I forgot. Here we go. I should have put this inside the exception, so cancel, cut that. There we go. And as you can see, it's missing a match. So what this did, it only passed 2 arguments instead of the expected 3, as we said before. So what we need to do in order to fix this error, we have to define our default values of our constructor arguments. So here we have 0, and we're also going to have, for the imaginary part, 0. As you can see, it's going to work now. So the real part is 2, and the imaginary part is 0. Okay, moving on. So what we did here is basically we just print everything out, and everything is all good. So now in our next example, let's say we want to pass sequences to our class itself. So we're going to do that in the following way. So let's erase this. So C equals complex, and then we're going to say our 2 attributes are as follows: 2, 3, and 1, 2, 3, like this. So these are our attributes. And then when we print them out, everything is fine and dandy. But what we're going to do later on, we want to, let's say, because if this is the case, if everything's fine and dandy when we add sequences, then we can put in anything here. So what's to stop the user from inputting characters, which is basically not what this class does. It's a simulation of complex numbers, and you can't have other things other than float integers as our passed arguments. So what we're going to do inside our constructor method, we're going to define some restrictions to our constructor arguments. So we're going to say if the real component is not a integer or float, then, or if, or if, no, we don't need if, or if the imaginary part is not the same case, if it's not in integer or float. So if it's not a float or integer, if it's not a type int or float, then we're going to say, we're going to raise the exception. We're going to say, hey, this is not a args. We're going to say args not, let's say args are not numbers. So we're going to say, okay, so you have to input numbers. So we're going to build this. As you can see, we got the exception, args are not numbers. And so keep this in mind that try, we're going to actually add try back here. So this is it's a good practice to have try and except statements, because it's generally good practice, and it's for the sake of the interpreter. So except exception as e, and then we're going to say print e. Oops. And we have so here we go. Wait, indentation. Wait, what? Oh, right. See, it even defines our indentation errors. So there we go. And it got rid of all that error, that bunch of garbage text we didn't want. So now it just says args are not numbers. So, and then when we fix this, it's pretty much, so let's say this is 2, and this is 3, 4, okay, 4. And then there you go. And that's pretty much it for this tutorial. We hope to see you next time. So now let's talk about class methods. Methods are special functions inside the body of a class, as you can see here, as I wrote up here. So each method has the self argument as the first parameter. And we're gonna let's see how the syntax is written. So we have def, and then we're gonna say get real self as our argument, and then we're gonna say return self dot real. We're also do the same thing for the imaginary part. So we're gonna have get imag self, and then we're gonna say return self dot imag. All right. So what these are they are inspectors, or they're also called getters. So we can actually use these methods by doing the following. So we initialize our class instance. So let's say complex with the attributes arguments 2.5 and 5.2, and then we're going to print, and we're going to use the actual methods we just typed out. So real, and then we have C get image. As you can see, it auto fills for us right here. So when we print, it checks out. So we also have two other methods we're going to define right now. So now we had getters, or inspectors as we call them. We're also now going to have mutators or setters. What these do, they're used to change the value defined in the method. So set real, in this case we're doing the real and imaginary parts. So we're going to have self and val arguments. And these arguments, so we have the self from before and we have the new value. So we're going to set self, so we have self dot real equals val. So we did this for the real, and then the real part, and then we're going to do the same thing for the imaginary part. So self, whoops, not set real, image self. I am all over the place today, so set self, there we go, sorry about that. So we have val, okay, we have val, and we have self, let's delete that. There we go. So colon, and all right, so we do the same thing. So self image this time, image equals val. All right, so now we have our getters and setters, or inspectors and mutators. So let's do this same code we did here, but in a different way this time. So we're going to erase this. So C equals complex. So we're going to say just without any values passed. So we have C.setReal. So we're using this to change the value. Remember, we defined before that as 0 initially. So we're changing the value now to 1. And we have the set well, we could do set real. You could do either way, whatever. Set to 2. And then when we print, so we're going to print this now. Print. And then we're going to say C.getReal. So get is used to return the value, as you can see in this code that's defined up here. So we get real, and we get image. Oops, I forgot the parentheses. Like in all methods, you should define the parentheses. You should not forget the parentheses themselves. And there we go. So some might argue that these methods aren't really needed, but later on, we'll see that this isn't the case. Because in object-oriented programming, we should take care to control access to data. So the user shouldn't really be messing with whatever's in the class, because we'll see later on that we make these attributes private. So I'll explain that more in detail in the next tutorial. So be sure to tune in next time. So basically, I stopped last time at the question. So what's stopping us from basically accessing a value in the class directly and like setting it directly instead of going over getters and setters? Well, in object-oriented programming, oftentimes, it's actually the practice of object-oriented programming to define all variables that are used in the class as private, because the person who uses the class shouldn't know what's going on inside the class, and they should be just working with the methods and not the variables themselves. So now we're going to define all of wherever you see real and image, the imaginary parts, as private, which is done with the 2 underscores in front of the name. So we're just going to add those 2 underscores in front of every time we see real and image. So we're defining each wherever you ever see it as private. So these variables are private now. Let me just check. Here we go. All right, so I believe everything is good here. Let me just do one last check. So self-real, private, return self-real, self-image, self equals val. All right, everything is good to go. So in object-oriented programming, everything is private. So, and then we're going to add 2 more things to this. We're going to add some restrictions. So we don't want the case where the user inputs something that isn't of the type int or float. So we're going to say in our setters, we're going to say not in int or float. We're going to say raise the exception. And it's going to say real part must be a number. And then we're also going to do the same thing for the imaginary part. There we go. There we go. And then we're just going to change this to image. All right. So here we have these restrictions. Now we're going to check for this. So let's erase this. We're going to do try and accept. So let's write this out. So we're going to say c.setReal. And here we go, we're using a sequence this time, and then we're going to say except exception, and then we're going to say as e, and then here we go, print e. As you can see, this actually worked. So, and it's also like, so this is how we should be doing things in object-oriented programming. So define your variables as private, and be sure to have restrictions on what can be input. So, and we're also going to do the same thing for, as you can see, we can't access private values because when you make them private, they can't be accessed outside and they're treated as non-existent. So C basically doesn't have this because it's private. And that's pretty much for that example. So let's move on to the next example to help illustrate how to properly use OOP mechanisms. So we're going to introduce some other methods into our examples. So let's delete this. We have all this from before, and now we're going to use imported module. We're going to use the math. So here we go. Let's make some more. Methods. So what these methods are going to do, they're basically going to define the polar form of given complex numbers. So let's define some. Excuse me. So we have get real, set real, and then we're going to have before sets, the setters, we're going to have define. We're going to say they're going to be called get fee. So we have get fee, and then we're going to also have define. We're also going to have oops, I should have said before that to be more organized. So we're going to have def modulus. So it's going to be called define. We're going to call it get modulus. Have the argument itself. All right, let's type this out. So what these do, get modulus is going to return. So we're going to do math. We're using modules here. Square root. So square root. We're accessing self get real times self dot get real, and then we're going to do plus self dot get image times self dot get image. So this is going to solve the modulus of this part. So here we go. That's that. Pretty long, but this is just an example. So as you can see, I'm basically making methods that will be used to simulate the complex number. So in whatever you're doing with the class, you have methods that have attributes and you have methods that reflect the actual real-life applications of your object or your class, of the class itself. So now we're going to do fee, and then return. We're going to have return math dot a10 of 2 of self dot get image colon, and then we're going to have, so we're getting the tangent 2 of the following. So self get real, and there we go. So let's actually clean this up a little, make it more readable. So it's also good practice to make things more readable, have like a space between each method or function, whatever you call it. And there you go. All right, and so now it should work. So let's do the following. We're going to define complex. Here we go. Complex. So -3 and 4. There's our instance of the class. Print. And then now we're going to do get. See, we have all kinds of functions now. So we're going to have get modulus. And then we also have c.getFee. Don't forget your parentheses. And there we go. Those are our answers. So we define the polar form of the given complex numbers. It should be noted here that we can call a method from another method. That is what we did in methods getModules and getFee. We called getters real and imaginary of the real imaginary components. So we used other methods inside one method so we can use them within each other. So knowing this, we can have the following constructor. So instead of having this from before, we have the following. So we can erase this, and we could say self dot set real, and we have self dot set image, and then we have image. And there we go. So basically, we went from what we did doing it directly, like this. Hold on, let me just erase all this. Instead of having it look like this and directly doing it, we can do the following. We basically use the method to set these values in the initialization of an instance. And that's pretty much it for the example. We hope to see you next time. So as we've seen before, it is possible to add two sequences or two strings. It is also possible to multiply a string by some integer. So if we want our class to use operators such as these and on other special operators, then we have to use operator overloading. For example, it would be useful if we defined an operator for adding two complex numbers, like while using our class right here. This would also allow us to control instance variables without writing getters and setters. So let's dive right into our example. So I'm going to use operator overloading for addition, or the plus symbol, plus operator. So in order for me to add two complex numbers. So in order to do that, I'm going to define a couple methods right here, and I'll explain what they are in a second. So we're going to have def 2 underscore string 2 underscores. We're going to have self, and then we're going to have, just self, the self attribute. So what this is going to do, it's going to display a string of our result, and I'll explain more in details just in a sec. Let me just write it out. Return string. We're going to return a string of, so we're going to convert our real part of the number to a string, and then we're going to concatenate it. So plus with a plus to make the complex number form properly. We don't need spaces in there. We're going to concatenate it. Now we're going to concatenate. Excuse me. We're going to concatenate it now with the imaginary part converted to a string. So we have get image. And then we're gonna add now with an I at the end. I. All right, that's that part. And now here's our overloading. Here's the part where that operator overloading comes in. So we're gonna make a method add for addition. So it's gonna have self and other. It's going to add two complex numbers together. So what we want to have, we're gonna return a complex number which consists of self. The real part is going to consist of get real plus the other get real. It's the other real number part plus the other real part. And then we're going to add the imaginary parts together. Let me just check. Self get image plus other get image. Let me just check that. Oops, there's a syntax error. See, I just like to check. Line 37. Oh, I forgot the colon. Everything checks out. Yep. All right. So now with these, we can add them up. We can add these two complex numbers I made right here. here. So we're going to print, and we're going to print A plus B. And that checks out, right? Here's our result. So in this example, we overloaded with the plus operator. That is, we define the addition of two complex numbers using this method right here. We should also mention the term method overriding. In our example, that's this method right here for the string. You might say the operator overloading works on the overriding principles, which is closely related to the concepts of inheritance. Because overriding means changing the implementation of a method which is given by one of the method's ancestors. So we basically used the values getReal and getImage to display a string of our result. And through overriding, a class can copy some other class and modify it if required. So this method used these as needed and as required and obtained the string. We'll talk about this a bit more when we get to the inheritance topic. But for now, in our example, we used overriding to print out the complex numbers in the complex number in a specified format without calling getters and setters. As you can see, we just returned a string. Now let's get back to the main topic. So, other than the addition operator, which is a binary operator, we can also overload a wide variety of both unary and binary operators. And unlike binary operators, unary operators are performed on one operand only. So in our next version of our complex class, we will define some other operators. So let's see what we can do. We're going to make ones for multiplication and division. So we're going to overload. We're going to make a method for multiplication. And we're going to have self attributes and self and other as our arguments. So now in these two following methods, we're going to check if this value right here is a normal number or if it's a complex number. So if the type of other is in int or float, meaning if it's a float, or int if it's a floating point number or integer, we're going to say we're going to return a complex number where the real part is multiplied by this number, other, and the imaginary part is also divided by this number, other. Self get imag, there we go, times other. So, but what in the other case, this other case assumes that the number will be complex. So we're going to return a complex number, which consists of, let's see, here we go, self.getReal times other other.getReal, my bad, other.getReal, and then we're going to have minus the self.image times other.getImage. That's for the real part. And for the imaginary part, we're going to have self.getImage times other.getImage plus self.getReal times other.getReal. Everything checks out with that. So now we can actually do multiplication. So let's do that right now. So we're going to print a new complex number. It's going to be A times B. Whoops. A times B. And there's our answer for that. We can also we don't have to have another complex number. We can also just use a number like 2, and it works. So that's multiplication. And now let's move on to our division overloading operator. So let me just see, escape that. Let's see right here. So this one's a little more complicated, but you'll have, bear with me. So in older versions of Python, overloading with division is done like this with just div. However, I'm running Python 3.5, so I have to use true div. So be sure to use true div and not just div when working in Python version 3. All right, so let's get this underway. So self and other. So in this one, we're also checking if it's a regular number, or if this other argument is a regular number or a complex number. So we're going to do type if type of other is an integer or a float. We are going to just do the following. We're going to return a complex number that is the following. So self get real is divided by the typecasted float of other in case it's integer, because when doing division, remember you should use float because there might be a decimal number. It might be a decimal number and not an integer. And the imaginary part is going to be self.getImag divided by float, same thing as before, float of typecasted other typecasted to float. All right, so let's just test that. Yep, everything checks out. All right, now let's go on to the next part. So we're gonna have the else statement now, and this is where we assume that it's a complex number this argument is a complex number. So here we go. So we're gonna set a couple variables set to equal to some parts of the complex numbers to make things more simple for us. So we're gonna have A, B, C, and D respectively equal to the following. So self get real, comma self dot get imag, comma other dot get real, comma other dot get imag. Since we're dealing with division of complex numbers, we have to set a nominator. So nominator is going to be equal to the following. We're going to have C times C plus D times D. And now with everything set up, we can return the following. So we're going to return a complex number, which is the following. So we have A times C, not capital C, A times C plus, let's see, B times D. And then outside that, we're going to divide it by a nominator. That's our real part. And then comma, the imaginary part is going to be the following. It's going to be B times C minus A times D. Let's space that out. There we go. And divided by nominator. Let's check invalid syntax, just checking my mistakes right here. Oops, I forgot a parentheses. Wait, no. Wait, something's missing. Let me just check. Complex. Maybe there needs another one. Nope. So I opened one. Oh, here we go. There we go. Just always remember to always check your parentheses. Yep. There we go. So now that all checks out, and now let's see how this division works. So let's do A divided by B now. Oops, spacing is weird. A divided by B. And that worked out. And now let's do, instead of using a complex number, let's do, for example, B divided by 2. And that checks out. So now we've defined two more operators in operator overloading. And so with this, we conclude this tutorial. So in our previous tutorials, we learned the main principles of object-oriented programming in Python. In this tutorial, we'll go over some other important concepts. Now, if we want our class instances to have some common information about something, for example, a number of currently instantiated objects in the running program, we can achieve this through a shared variable. This is almost equivalent to a static variable in C++. For those who are familiar, for those who are familiar with the programming language anyway. In Python, using the shared variable can be used as follows. So let's escape that. Alright, so we're going to make a class called student. Oops. Student. Alright, it's going to be called student. Actually, let's not use this. Class student is going to inherit object, the object class, and then we're going to say the following. So quote, 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 student, quote, 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 and then number of students attribute, this is our shared variable, equals 0. And then we're going to define our constructor method for, here we go, self, name, and index. And then we're going to have self.name equals name, self.index equals index, and then we're going to have our shared variable right here. So student dot number of students plus equals 1. So every time we instantiate a new student, we will add number of students. This will increase by 1. So let's do S1 equals student. We're going to call him Pythonsky, and he's going to have the index 1, 2, 3, 4, 5. And we're going to have another student student equals Guido van Rossum. And then we're going to have 35, 6, 7. So now we can access the shared variable in the following way. So we're going to have a print, and then we're going to say, so we have print, and we're going to say student dot number of students, and we're going to say S1 number of students, and S2 dot number of students. And as you can see, in all cases, in all instances, it's 2. So another important concept in OOP is a destructor. Destructors are of great importance when it comes to memory management. An example of this is when we use the following operator. It's called del, as you can see is highlighted in pink, delete. For example, if we want to delete one of the students and print out the number of students, we will see the result is incorrect. So we're going to do this. So we have our initialized students instances, and we're going to say delete. We're going to say delete S1. Oops, S1. And then we're going to print now the number of students. Number of students. As you can see, it's still 2, but we deleted 1, so it should be 1. So the purpose of the deconstructor is to release the resources and ensure the adequate functioning of the program. The destructor for our class should be decrement the number of students when a student is deleted. So we have to add another method. In this case, we're going to define a new method. It's going to be for del, and we're going to say self, and it's going to be student dot number of students minus equals 1. So every time you use a destructor, it's going to decrement this value. So now, when we actually do this, it's going to be 1. And destructors are mostly used for memory management. However, in Python, we don't really have to worry about this because there's a mechanism called the garbage collector, which is used for managing memory. And that's pretty much it.